Earthquakes don't give warnings, but our codes must. With the release of IS 1893-2025, seismic design in India has taken a major leap forward, moving closer to global best practices and performance based thinking. Hey friends, welcome back to Civil Engineering Mastery. IS 1893-2025 Part 1 marks a fundamental shift in how seismic forces are defined and applied in India. This is not just a revision of equations, it is a change in seismic hazard philosophy, ground motion definition, and performance expectation. In this video, let's discuss 5 core changes introduced in IS 1893-2025 clearly, concisely from a code perspective. So, without further delay, let's begin now. Earlier, seismic design mainly dependent on zone numbers. IS 1893-2025 now treats seismic hazard as probabilistic. This means earthquakes are considered based on chance and likelihood, not just one fixed value. Design forces are linked to probability over the life of the building. A major update is the introduction of new highest seismic risk zone, Zone 6. Zone 6 represents regions with very high seismic potential. So the buildings here must be designed for higher zone factors, increased base shear and strict ductile detailing. IS 1893-2025 gives strong importance to local soil conditions. The design response spectrum now depends on site specific soil class. Soft soil can amplify earthquake forces even in lower zones. So, same zone does not mean same seismic demand. If you look at the curves for site class A/B, C, and D, how they have different shapes and more importantly, different natural period. This means the seismic demand on your structure is now directly customized to the specific soil profile at your location, which is much more precise approach than we had before. The natural period earlier was 6 seconds and now it is extended up to 10 seconds. Earlier, vertical earthquake forces were mostly ignored. IS 1893-2025 now makes the vertical seismic component mandatory. Ignoring vertical motion can lead to unexpected axial force reversals and overstress in compression and tension members. IS 1893-2025 ensures that structures are checked for combined horizontal and vertical seismic actions, leading to safe and more realistic design. One of the most practical and life safety focused update is the mandatory design of non-structural components, referred to as architectural, electrical and utility components. Historically, most earthquake injuries and losses occurs due to false ceiling, collapsed partitions, damaged services and equipment failure. So, IS 1893-2025 clearly states that AEUs must be seismically restrained, designed for appropriate seismic forces, and anchored properly. This includes false ceilings, facades, HVAC systems, water tanks, and electrical panels. So, friends, the message is clear here. A structure is not earthquake safe unless its non structural components are also safe. To conclude, IS 1893-2025 represents a clear shift towards probabilistic, site specific, and performance based seismic design. Understanding these changes is essential for every engineer designing structures in seismic regions. So, friends, if you like the explanation, hit the like button and also share it with your friends. If you want any particular class of IS 1893-2025 needs to be explained, please mention that in the comment box and don't forget to subscribe this channel for more videos. Thank you for watching.